Okay, can you guys hear me now? Okay, great. So, as I was saying, this topic basically consists of around 4 to 5, in some cases even 6 marks. Okay, that's what my analysis tell me. Sometimes you have. So it all depends on how many parts you have. Okay, so somewhere between 5 to 7 marks is the average. Okay, so let's start. Let's finally start. Let me start with the notes. So I'll give you guys some notes first, and then we will start solving some past paper questions. So we can, inshallah, start and finish this in the same class. ओ लेवल एड मैथ्स लाइव स्ट्रीम सो इफ़ योर एग्ज़ाम इज़ इन मई जून तो फिर आप आराम से बैठें, टेंशन की बात नहीं है. Right now I'm focusing more on students who have their exam in October, November. Okay, mainly A level math students who have their retake exam in October, November. This class is going to be around an hour, hour and a half. Okay, now let's finally start. Discrete random variable. Okay, I'll do that after today's class. All right, Sayyid Arabi, I'll do that after today's class, inshallah. Don't worry. So today is the 11th of September. What about O-level students appearing in October, November? So I already have plenty of content on my channel. I would suggest you make use of that for now. I'll see if I can do a stream here and there of O-level math and maths. Okay, but I already have plenty of content on my channel already. Anyway, so let's talk about discrete random variable. Okay, so in short, we also call this DRV, and the main thing we do in this topic is that probability distribution, which basically means we look at every probability and we look at every outcome and we write down its respective probability. This is S1, so it doesn't matter whether you're giving S1 in AS or A2, it's S1, which is paper 5. Okay, usually people do it in AS, but people do it in A2 also. So what exactly do we mean by discrete? Discrete basically means one that may take on only a number of countable, so emphasis on the word countable, distinct values, such as 0, 1, 2. Okay, so you have discrete. The opposite of discrete is basically continuous. Continuous are so for example, if you're measuring height, so height is a continuous variable. Why? Because in between, let's say 5 feet 5 and 5 feet 6, there are so many possible options. Okay, it's not like you're either going to be 5 feet 5 or 5 feet 6. You could be a lot of values in between. Okay, similarly, it's not that you're either going to be 5 feet or 6 feet. In between, all you can be all possible values in between 5 and 6. Okay, but if let's say you're tossing a coin, my voice is low, is that correct? Is that for everyone or just for the person who's just mentioned it? Is my voice low? Yes, no? Can you guys please confirm? It's fine for you? Okay, I'm afraid the problem is at your end. Who's that? Mera, I'm afraid the problem is at your end. Anyway, so we're talking about one that may only take a number of countable distinct values. Okay, so like for example, if you toss a coin, and let's say you toss a coin 3 times, so how many heads are we expecting? We're expecting 0, 1, 2, or 3. Okay, so nothing in between, nothing in between 0 and 1, nothing in between 1 and 2, nothing in between 3 and 4. We're only expecting countable distinct outcomes. Now, another thing to keep in mind that whenever we're solving a discrete random variable question is that the number of trials are fixed. Okay, so there will be a fixed number of trials. That means if you're tossing a coin, you're tossing a coin 5 times. Actually, not 5 times. 5 times, you'll have lesser than that. But it's not like you're going to keep on tossing the coin like we do in geometric distribution. Okay, which we will do later. Now, another thing to keep in mind is that probability, this is very important, probability distribution table is drawn to find probabilities. Okay, so we make a probability distribution table to find probabilities. Okay. Then how do we define it? Now we don't have to do this ourselves. Most of it is done in the question. Okay. So the random variables are denoted using capital letters, but this is not always true. Okay. So you can have like lowercase letters also. It's usually x and y, etc., etc., and their respective probabilities using lowercase letters such as x and y. But you don't have to worry about it because the table will already be given to you, and you don't have to write that down yourself. You only have to find out the probabilities. Okay. Now let's do an example. So the example is that let x be the number of times head is obtained when a coin is tossed 3 times. Okay, so let x be the number of times a head is obtained when a coin is tossed 3 times. This is easier than IGCSE. All right. If you're saying so far it's easier, well, wait till it gets difficult. But some questions, yes, are very easy, but some questions are difficult. Okay. So if you're tossing a coin and we're tossing a coin 3 times and we're recording the number of times head is obtained, so what are the possible number of times you can expect a head? So you can expect to get a head 0 times, 1 time, 2 times, and 3 times. Okay, so this is what we mean when we say probability distribution. So here we have 0, and then we're going to write down its respective probability, and then we're going to have another column for 1, we're going to write down its respective probability, and then we're going to make another column for 2, write down its respective probability, and then we're going to make another one for 3, write down its respective probability. Okay, now we're not going to write down the probability right now. We will do some actual past paper questions, but right now let's just call them A, B, C, D. Okay, now rule of probability, remember, it applies everywhere. That is the sum of all probabilities of a discrete random variable, so I'm going to call it D or V now, is 1. Okay, that basically means A plus B plus C plus D is equal to 1. All right, good to hear that. Sir, please make a stream for maths most difficult questions part 2. Okay. Now, another two important things that you will be calculate. One is the mean, okay, which is also called expected value, or it's referred to as E of x. Now the formulas will be given, but don't entirely rely. I mean, if you do enough questions for practice, you will eventually have all the formulas memorized. Okay, so E of x is basically sigma x multiplied by the probability of x. Okay, so that means you multiply x, that is the outcome, multiplied by its respective probability, and then add it up. Okay, so I'll write down over here that this basically means the outcome multiplied by its respective probability. And sum it up. Okay, that's how it works. All right, now let's talk about, so that's mean or E of x. Then another thing that we have to calculate is called the variance. Once again, this formula will be given, but you will have these formulas memorized if you do enough questions. So variance of x is equals to sigma or summation. Now be careful over here. It's x squared multiplied by p of x. That means the outcome squared multiplied by its probability minus the mean squared minus the expected value of x, the whole thing squared. Okay, so this is the mean and this is basically outcome, square of outcome multiplied by its respective probability. Okay, now these notes will only make sense once we start solving some actual past paper questions. Okay, so we'll start off with some easy past paper questions, but before I do that, I like to make this chart which students can refer to when calculating probability. Okay, so in this column we're going to write down the term used, or you can say the phrases used. Okay, in fact let's change it to phrases. And in this column we're going to write down the inequality. All right, so if the question says or uses the phrase such as at most, okay, or no greater than, then, and let's say no greater than k, at most or no greater than k, what does that mean? That means we need to find out the probability of x, whatever the random variable is, being less than or equal to k. Okay, so if the question says at most or no greater than, that means it's lesser than or equal to. If the question says fewer than k, okay, k could be any constant, fewer than 2, fewer than 3, fewer than 5, that means we're talking about the probability of x being less than k. If the question says at least k or no less than, that's also very common. That means we have to calculate the probability of x being greater than or equal to k. Okay. Alize, I don't have one, but I do plan on making one where I will share all my notes with you guys. Okay, so I'll do that inshallah this week only, and I'll announce on my Instagram. I'll share the link on my Instagram. You guys can get it from there. Okay. All right, and then there is greater than, or even if the question says more than k, same concept, greater than or more than. That means probability of x is greater than k. Okay, now remember these phrases when we're solving past papers, and I have a question which we are going to solve, and here it is. We're going to do this step by step, and obviously that's not how we're going to solve every single question, just this one. And then after this question we will have a more direct approach. Okay, so this question we'll do step by step. I'll write everything down in steps as to what you need to do. Okay, so remember, first read the question from the start till the very end so that you get familiar, you understand the context of the question, what it is that the question has mentioned, and then we'll read it again and we'll pick some specific information. So it's a fair spinner which has sides numbered 1, 2, 2. Another fair spinner has sides numbered -2, 0, 1. Each spinner is spun. The number on the side on which a spinner comes to rest is noted. The random variable x is the sum of the numbers for the two spinners. Okay, so how are we getting the random variable x? The random variable x is basically the sum of the numbers for the two spinners. Okay, so this is what the random variable x is. It's already defined in the question, so nothing to worry about. Okay. So what we're going to do is we are going to set up the probability distribution table. Okay, so let's write down the steps for that. So step one is that you define the this random variable, but that has already been done. Okay, the random variable is basically the number on the side on which the spinner is the random variable x is the sum. Okay, so this has already been done. Step 2 is that you identify all the values x, which is the random variable that can take, all the values x can possibly take. Okay, let's add the word possibly here. All the values that x can possibly take. Okay, so for that we can't just do that right away. We'll have to make a table. Okay, we'll have to basically write down all the numbers and add them up. Okay, so very similar to O levels, if you guys remember. In O levels we had questions like these where you would roll 2 dice and you would record their sum. So 1, 2, 2, the numbers on one spinner, and minus 2, 0, 1, the numbers on the other spinner, minus 2, 0, 1. And remember, what are we recording? We're recording their sum, which is why I have put a plus sign here. Okay, so 1 plus minus 2, that's minus 1. 0 plus 1, that's 1. 1 plus 1, that's 2. This is 0, this is 2, this is 3. And here's 0. No, wait, here's not 0. Yeah, it is 0. And 2 plus 0 is 2, and 2 plus 1 is 3. Okay. So that means now we have all the values that x can take. Okay, so in a table I'm going to write that down in ascending order. So x can be equal to minus 1, which is the sum. X can be equal to 0, x can be equal to 1, x can be equal to 2, x can be equal to 3. Okay, so we have basically found out all the possible values that x can take. Okay, or all the values that x can possibly take. Now what's the next step? The next step is to find out the respective probability. Okay, so that's what we're going to do in the next step. In the next step, we're going to find out the probability of each outcome. So here we're going to write down probability of x equals to x. That means the probability of each outcome. So let's see, how many times do we see minus 1? We see minus 1 occurring once. Out of how many times? Out of 1, 2, 3, 4, 5, 6, 7, 8, 9. That means the probability of minus 1, the probability of sum being minus 1, is equal to 1 over 9. How many times do we see 0 out of 9? We see 0 2 times, so that means the probability of 0 is 2 out of 9. How many times do we see 1? We just see it once, which is 1 out of 9. How many times do we see 2? We see 2 occurring thrice out of 9 times, so 3 out of 9. How many times do we see 3? We see 3 occur a total of 2 times from a total of 9, so that's 2 over 9. Now if you want to check, make sure that these probabilities add up to 1. If these probabilities don't add up to 1, that means you've done something wrong. So let's just add the numerators and see if it's equal to 9 or not. 1 plus 2, that's 3. 3 plus 1 is 4. 4 plus 3 is 7. 7 plus 2 is 9. So that means we've done everything correctly. Okay, so that's it. That's the answer to the first part. Okay, so the first part was to draw up the probability distribution table for x. We have done that, and we get how many marks? We get 3 marks. Okay, now this was a relatively straightforward question. Don't immediately form your opinion about the difficulty level of this concept or of this chapter. Things will get difficult, but we will solve difficult questions as well, don't worry. Okay, then the question says find e of x and the variance of x. Okay, so e of x, we just wrote down the formula earlier. It's basically summation x multiplied by its respective probability. Okay, so x multiplied by its respective probability. Okay, so that means minus 1 multiplied by its respective probability, which is 1 upon 9, plus 0 multiplied by its respective probability, that's 2 upon 9, plus 1 multiplied by its respective probability, that's 1 upon 9, plus 2 multiplied by its respective probability, that's 3 over 9, plus 3 multiplied by its respective probability, that's also 2 over 9. Okay, so I have the answer written already. It's 12 over 9, or if you simplify, that's equal to 4 upon 3. Okay, now let's find out the variance. Okay, we have plenty of space, but still be efficient with space utilization. So the variance of x is equals to, once again, summation x squared, that is the outcome squared, multiplied by the probability minus the mean squared. Now we have already figured out the mean, so we don't have to worry about that anymore. But this thing right here is what we have to worry about. Okay, so x squared basically means, if you want, you can add another column here of x squared, which means 1, 0, 1, 4, 9. Okay, now this is what we're going to multiply by the respective probabilities, and we're going to keep on adding them up. Okay, so 1 multiplied by 1 upon 9 plus 0 multiplied by 1 upon 9 plus 1 again, okay, 1 again multiplied by 1 upon 9, and 2 squared, so that's 4 multiplied by 3 upon 9, and what's left? 3 squared. Yeah, 3 squared, which is 9 multiplied by its respective probability, which is 2 upon 9. And do not forget that from this you have to subtract the square of the mean, which is 4 upon 3, the whole thing squared. And once again, I figured this out. This is 32 upon 9 minus 16 upon 9, which is equal to 16 upon 9. And there you go, fellas. That's the answer to the variance, and this is the answer to the mean. Now, as always, take a good look at it. Let me know what your thoughts are, and let me know if you have any questions. In the meantime, I'm just going to fix the mic. So it turns out I'm not connected to the external mic. I'm connected to the wrong mic. Okay, so just give me a minute. Let me try and fix it. If I can, brilliant. If not, then I guess there's nothing we can do about it. Hello. 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 Okay, it's fixed now. Sir, please P3 के lecture सारे topics की video बना के upload कर लें. Okay, I will be streaming P3. Don't worry about it. Will you be making a live on permutation? Yeah, I will be doing a live on permutation combination as well. Okay, that has been on my list for a very long time. Sir, will you do any S2 topics? No, but I don't know S2 topics. I believe Sir Zain streams S2. So if you should check it out if you have S2. I'm afraid you don't find a lot of content on YouTube on S2. But as far as permutations, combinations is concerned, I will do that also, inshallah. Okay. Anyway, now let's talk about the second question. Once again, we'll do some fairly easy questions before we move on to the difficult questions. All right. So it says Noor has 3 t-shirts, 4 blouses, and 5 jumpers. She chooses 3 items at random. The random variable x is the number of t-shirts chosen. Okay. Now, the reason why I've chosen this question is students get confused that how come we have 3 different outcomes, all right, or 3 types of outcomes. And keeping that in mind, how do we set up a probability distribution table? Okay, so we will come to that. That's in part 2. But first, let's do part 1. Show that the probability that Noor chooses exactly 1 t-shirt is 27 upon 55. So once again, the emphasis on the first part is on t-shirt. So here's what we're going to do. She has a total of 12, whatever you want to call them. Okay, 12 clothes, whatever you want to call them. Okay, so the total number of items are 12. Okay, now of these 12, 3 are t-shirts, 4 are blouses, and 5 are jumpers. Okay, so we have 3 t-shirts, 4 blouses, and 5 jumpers. Now notice that the question is only interested in t-shirts. So that means what we're going to do is we're going to classify them into 2 categories. One is t-shirt, which we already have. The other, we're going to merge them, that is blouses and jumpers. Okay, we're going to merge them and we're going to call them t prime, which basically means that not t-shirt. So it's either a t-shirt or it's not a t-shirt. And how does this help? This will help us in calculating probability. That means the probability of getting a t-shirt is now 3 upon 12, since there are a total of 3 t-shirts and 12 total options to choose from. And the probability of not getting a t-shirt, okay, so t prime is basically representing not a t-shirt. Okay, t prime is representing not a t-shirt. So the probability of not obtaining a t-shirt is going to be 9 upon 12. Okay, so let's see what the question is asking. Show that the probability that Noor chooses exactly one t-shirt is 27 upon 55. So that can be done. Let's see how many ways that is possible. So it could be that she chooses a t-shirt and then not a t-shirt. Okay, sorry about that. Just a minute. I don't know what's happened to my screen. Just a minute. Fixing it right away. Okay, great. I hope it's visible again. All right. Yeah. So coming back, as I was saying. So the probability of choosing a t-shirt, the probability of choosing one t-shirt is can be done the following ways. T-shirt, not a t-shirt, and not a t-shirt. Okay? But if you think about it, this is not the only way. This is not the only way that she can choose one t-shirt. Okay? There are plenty of other ways. Okay? And what are those? One is that in the first draw, she can choose not a t-shirt, and then in the second draw, she can choose a t-shirt, and then in the third draw, she can choose, once again, not a t-shirt. And then there is another way that is not a t-shirt, not a t-shirt, and then the t-shirt is basically the third item that she draws. Okay? So t-shirt, not a t-shirt, and t-shirt. Let's see what is the probability of that. So that is going to be 3 upon 12. Remember, since she's choosing 3, this has to be without replacement. So 3 upon 12 into 9 upon 11 into 8 upon 10. Okay? Now, if you think about it, the probability of every other outcome, okay, the probability of the different orders that I've listed actually will be the same. So instead of working it out one by one and then adding them up, I'm simply going to multiply this by 3. And the reason behind doing that is because that she can choose one t-shirt a total of 3 ways. Therefore, we're just going to multiply it by 3. Okay? So let's see what do we get. If you work this out correctly, you will get 27 upon 55 as your final answer, which you can't simplify, and that's what's given in the question. Okay? So let me check. Let's see what do we get. We get 3 divided by 3 into 9 into 8 divided by bracket open 12 into 11 into 10 into 3 27 over 55. That's correct. Okay, now part 2. Now part 2 says draw up the probability distribution table for x. All right, how can I make a probability distribution table for x? So what are the, considering that she's choosing 3 items at random, tell me the number of t-shirts that she can get. Tell me all the possible number of t-shirts that she can get if she is drawing 3 items at random and considering that there are 3 t-shirts altogether. Question for you guys. So once again, the probability of getting a t-shirt is 3 upon 12 and the probability of not getting a t-shirt is 9 upon 12. Okay. Now, It's possible that of the 3 items that she draws, she gets no t-shirt. That means 0 is an option. It's possible that she gets 1 t-shirt. It's possible that she gets 2 t-shirts. And it's also possible that she gets 3 t-shirts. Okay. Now, what about 4 t-shirts? Obviously, that's not possible. Okay. So, we're not going to take that into consideration. So, let me just get rid of this. There you go. Okay. Now, the question has already made us find out the probability of exactly 1 t-shirt. Okay, and what's that? That is 27 over 55. So let's write that down. This is 27 over 55. So 27 out of 55. Okay. Now, what's easier? Easier would be to find out the probability of getting no t-shirts and the probability of getting all 3 t-shirts. Okay. So let's find out the probability of x being equal to 0. That means no t-shirt. So that would be t prime, t prime, and t prime. No t-shirt, no t-shirt, no t-shirt. T-shirt. That means 9 upon 12 into 8 upon 11 into 7 upon 10. Okay. So there is no other. We don't have to consider a different order for this. So if you work this out, let's see what do we get. 9 into 8 into 7 divided by 12 into 11 into 10. So we get 21 over 55. What do we get? We get 21 over 55. Now let's find out the probability of getting 3 t-shirts, since that's much easier. Okay. Yeah, I will be posting this video after the stream ends. So that would be basically t-shirt in the first attempt, t-shirt in the second, and t-shirt in the third, which means 3 upon 12 into 2 upon 11 into 1 upon 10. Okay. So let's see what happens. 3 into 2 into 1 divided by 12 into 11 into 10. So we get 1 over 220. Now, how will I find out the probability of getting 2 t-shirts? For that, we can take the total probability, which is 1, and from that subtract the other probabilities. That is 21 over 55 minus 27 over 55 minus 1 over 220. And if you do this correctly, this is what you get. Probability of x equal to 2 is 27 over 220. And there you go. That's the answer. There's no follow-up question. You don't have to calculate e of x or the variance or anything. So that's it. This is the answer. Now, as always, take a good look at it. Let me know if you have any questions. Okay, now let's do another question. So, this is a fairly easy question. Now, I want to do questions where you have, yeah, let's do a question like this one. This is a slightly different question, different from the questions that we have solved so far. Let's see what it says. Yeah. So it says here, in a game, Jim throws 3 darts at a board. This is called a turn. The center of the board is called the bullseye. All right. The random variable x is the number of darts in a turn that hit the bullseye. The probability distribution of x is given in the following table. Okay. It is given that e of x equals to 0.55. Find the values of p and q. Okay. So how many unknowns do we have? We have 2 unknowns. And that means we need 2 equations. Now, one equation we can form with the help of the expected value of x. And we can do that. Let's write down the formula. So expected value of x is basically summation x multiplied by the respective probability. Okay. So that means 0 multiplied by 0.6 plus 1 multiplied by p plus 2 multiplied by q plus 3 multiplied by 0.05 equals to what? Equals to 0.55. But you can clearly see that this equation is not enough. So this gives us p plus 2q plus 0.15 equals to 0.55. And if we write it nicely, we have p plus 2q, which is equal to 0.4. And here we now have the first equation, okay, which, like I said, is clearly not enough. Now, how do we form the second equation? Well, we can form the second equation like this. If we simply do 0.6 plus p plus q plus 0.5, that is, if we add all the probabilities, the answer is going to be 1. Okay, so let's make p and q the subject. P and q is equals to 1 minus 0.5 minus 0.05 actually. 0.05. So what do we get? We get 0.35. Okay, so here we also have our second equation, and now it's just a matter of solving these two simultaneously and finding out, yeah, that's correct. Simultaneously solve them and find out the value of p and q. So you can use substitution, you can use elimination. It's really up to you what you want to use. So if actually it's easier to use elimination in a situation like this. P plus q equals to 0.35. If you subtract the two equations, immediately you have the value of q, which is equal to 0.05. And then you can find out the value of p by simply plugging in any one of the two equations, and p is equals to 0.3. Okay? So 4 easy marks, I would say. Now we have to find out the variance of x. Okay, so for variance of x, make another table where you write down the squares. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Now let's multiply this by their respective probability. 0 into 0.6 plus 1 into, now we know that p is equals to 0.3, so that means 1 into 0.3 plus 4 into q, and q is equals to 0.05, so that means 4 into 0.05. All right, then plus 9 multiplied by 0.05, and then do not forget to subtract the square of the mean, and once you do this correctly, you get 259 over 400. Okay, I know that you already planned your work for today. Could you please explain May, June, paper? Okay, let's see if I can do that. All right. Let's do another question. Okay, it's a fairly easy question. When I'll share this PDF with you guys, I'd suggest you guys download this and try it yourself. The question that I really want to solve with you guys is this one, where you have coins and you're throwing all of them at once. Okay, so these type of questions are tricky, especially when you have coin and you're throwing all of them at the same time. And not just that, that's not where it ends. The problem is that you have a biased coin and a fair coin. Okay? So I'm going to solve this question. I want you guys to pay close attention. I'm good, Hassan. Thank you for asking. I hope you're doing well also. So let's write down the 3 fair coins. It's always a good idea to assign them letters. So A, B, C, I'm going to call them the fair coins. D is the unfair coin. And here let's write down the probability of heads, and here let's write down the probability of tails. Okay, so I'm going to drag this up a little. There you go. Now, when we're talking about fair coins, that means the probability is even. So the probability of getting a heads is 0.5. The probability of getting a tails is 0.5. Once again, the probability of getting a heads, 0.5 on the fair coin. Probability of getting tails on the fair coin is also 0.5. Same goes for C. Okay, make sure to read the question carefully. It says one coin is biased and the other 3 coins are fair. Okay, so here I've classified them like this. A, B, and C are considered fair coins, and D is the biased one. Okay, good to hear that. Let me color code it. Blue. Okay, now as far as the biased coin is concerned, the probability of getting a heads on the biased coin is 0.6, and the probability of getting a tails on the biased coin is 0.4. Okay. Now we need to find out the probability of obtaining exactly one head. Now the question hasn't specified as to the head, where the head should be. Should it be on the biased coin or should it be on the fair coin? So that means we have to consider all possibilities. Now one thing to make a note of, okay, very important note. In fact, I should write this in red. So this note says that when all coins are thrown at the same time different orders are not to be considered. Only different outcomes will be considered. That means we will just consider one order and we'll stick to that. Okay? Only different outcomes will be considered. You can always rewind the stream. All right? Instead of me going back to the question, you can always rewind the stream. Okay, so remember this note. This will come in handy in a minute. Now let's write down one way that we can get exactly one head. Okay? Jazakallah, Hassan. Thank you so much. Means a lot. So one possible way is that A, which is the fair coin, gives you a tail. B, which is also a fair coin, gives you a tail. And C, which is also a fair coin, gives you a tail. And D, which is the biased coin, gives you a head. Okay? Now we are not, because all four coins are thrown at the same time, we're not throwing them one after the other. We're not going to consider different outcomes. This is the only order which we're going, we're not going to consider different order. This is the only order that we're going to consider. Okay? Why is that? That's because all the four coins are thrown at the same time. So we don't need to take into account all the possible orders like we did when we were doing the t-shirt question. Okay, here we don't have to do that. Okay, now what's the probability of getting a heads on the fair coin? That's 0.5, or tails, sorry. And then what's the probability of getting a tails on coin B, which is also the fair coin? And then 0.5. And then heads, that's 0.6. Okay, so let's write this down. We get 0.075. Okay, now this is where it gets tricky. So I want you guys to pay close attention. Okay, what is the probability of getting one head on the fair coin? Okay, let's write that down. What's the probability of getting a head on the fair coin? So that means it's possible that A, which is a fair coin, gives us a head, B, which is a fair coin, gives us a tail, and C, which is also a fair coin, gives us a tail. And D, on the other hand, which is a biased coin, also gives us a tail. Remember, we only want one head. Okay, we want exactly one head. Okay, now let's find out the probability of this. So once again, 0.5 into 0.5 into 0.5 multiplied by 0.4. Okay, now before you write this down, before you work this out, there's another thing that you have to consider. Now I said that we're not going to consider different orders, but we will consider different outcomes. Now notice here the head that we have is on A. Okay, the head that we have is on A. It's possible that you get the head on B, which is the other fair coin, and it's also possible that you get the head on C. So that means we need to consider different outcomes, not different orders, but different outcomes. So that means A may give you a tail, okay, but the head that you get, you might get it on B, and C will give you a tail, and D will also give you a tail. Also, it's possible that A gives you a head, B gives you a head, sorry, A gives you a tail, B also gives you a tail, and C is the fair coin that gives you a head, and D on the other hand gives you a tail as well. Okay, now notice that one thing common in all the possible outcomes that I've listed is that you're getting only one head. Okay, so I'll explain this one more time. So first we found out the probability of getting the head on the biased coin. Okay, then since we have three fair coins, we need to calculate the probability of getting the head on every single one of them. That is getting a head on A, getting a head on B, and getting a head on C. And all these probabilities, by the way, will be the same. Okay, so instead of working them out separately, what we can do is we can just find out the probability of 1 and multiply it by 3. And why is that? That's because there are a total of, let me do it with a different color. That the reason why we're multiplying it by 3, because there are a total of 3 ways that you can get a head on the fair coin. Why? Because that's the number of fair coins that you have. Why aren't there any more ways of getting ahead on the unfair coin or on the biased coin? Because we just have one biased coin. That's the reason. Okay? Now, let's work this out, see what do we get. 0.5 into 0.5 into 0.5 multiplied by 0.4 times 3, that is equal to 0.15. 0.15. Now 0.15 plus 0.75 should be equal to 0.225. That's what it is. So there you go. 0.225 is the answer. Okay. So I hope that's clear now. This is something that a lot of students tend to struggle with, especially when you have multiple coins of the same type and you're throwing all of them at once. We'll do another question similar to this, so don't worry about it. But I hope this question is clear. And remember this note that I've written. Okay. This note is to be taken very seriously. Very important note. Okay, now, Acha Hassan, to answer your question, you'll find out the schedule on the website. It's www.mathleadbysart.com. You'll find out the schedule, everything basically. Okay. Now, let's see what is the following part asking. Following part is saying complete the probability distribution table for x. Now we already have for 0, we already have for 1. Let's see what we can work out. Would it be easier to find out the probability of getting 2 heads or 3 heads? Question for you guys. Would it be easier to find out the probability of getting 2 heads or 3 heads? What do you guys suggest? I don't have the answer to that question, but I'd like to know what you guys suggest. Because if we can find out 1, we can obviously find out the remaining by simply subtracting all of them from 1. 3 heads? Alright. Let's do that. Let's find out the probability of getting 3 heads. Okay. So let's list one way that we can get 3 heads. Okay. That could be the fair coin A gives us a head. The fair coin B also gives us a head. The fair coin C gives us a head. And the biased coin D gives us a tail. Okay, so let's find out the probability of this. For that, let's use a neutral color. So this is simply going to be 0.5 into 0.5 into 0.5, or simply 0.5 cubed multiplied by 0.4. Okay. Now, this is where things can get tricky. Let's see what is the possibility of getting, remember we're calculating the probability of getting 3 heads. Okay, so we're calculating the probability of x equal to 3. Okay, so the probability of x equal to 3, this is what we're calculating. Now another way that you can get 3 heads is this, that A, which is the fair coin, gives you a tail, B, which is a fair coin, gives you a head, C, which is a fair coin, gives you a head, and D, which is also which is a biased coin, also gives you a head. Okay. Now let's see what is the probability of this. So this is going to be once again 0.5 into 0.5 into 0.5 into 0.6. Okay. Now if you think about it, we can further shuffle these. Okay, we can further shuffle these. The emphasis is that we should just get 3 heads. So it's possible that A gives you a head, B gives you a tail, and C gives you a head, and the biased coin also gives you a head. So once again, you can see that we have 3 heads. Another possibility is that A gives you a head, B gives you a head, C gives you a tail, and D, which is the biased coin, gives you a head. So once again, you can see that these are all the different ways we can get 3 heads. Okay, so in all these outcomes, we get 3 heads. Okay, so let's find out the probability of 1, which we already have, and you can see that the rest of the probabilities will remain the same, so all we have to do is simply multiply it by 3. Okay, so let's write this down. This is equal to 0.5 into 0.5 into 0.5 into 0.4. I think it's going to be 0.05. Let's work it out. 0.5 cubed into 0.4. 0.05. And then let's work this out. 0.5 cubed into 0.6 into 3. So this is 0.225. So if you add 0.225 and 0.05 together, you get 0.275. Here it is, 0.275. Now, in order to find out the probability of x equal to 2, simply subtract 1 from, simply sum this up and subtract it from 1. So 0.05 plus 0.225 plus 0.275 plus 0.075, and that gives us 0.1 minus the answer, 0.375. There you go. Okay. So lengthy, yes, but and also tricky. Okay, lengthy and tricky, and very easy to get it wrong if you're not paying attention. Okay, then the next question says, given that e of x equals to 2.1, find the value of the variance. Okay, how can we find out the variance? Once again, very simple. The variance of x is sum of x squared multiplied by its probability minus e of x, which thankfully is already given, squared. Okay, so just a second, I'm going to copy paste the table. Oh yeah, ignore that. Funny, nobody else pointed that out. Ignore that. In fact, I'll just hide it to avoid the confusion. There you go. Okay, so summation x square multiplied by p of x minus, I basically did a pulley stream yesterday. I forgot to hide that. Forgot to change it actually. Anyway, so so 0 squared is 0, 1 squared is 1, 2 squared is 4, and then 9, and then 16. So we're going to multiply them. Okay, and from that we're going to subtract the square of the mean. So that means 0 multiplied by 0.05, which becomes irrelevant obviously, plus 1 multiplied, this is x square in case you're wondering, 1 multiplied by 0.225 plus 4 multiplied by 0.375 plus 9 multiplied by 0.275 plus 16 multiplied by 0.075, and from that we're going to subtract 2.1 squared. Okay, so I don't know what the answer is, but you can work this out and you'll get the final answer. Okay, any questions? If yes, let me know. $0.99, I don't know. Let's find out. So we have 0 plus 1 into 0.225 plus 4 into 0.375 plus 9 into 0.275 plus 16 into 0.075 minus 2.1 squared. Yeah, you're right, 0.99 is the correct answer. Good job. Okay, now let's do another question which is related to coins, because it's the coin question that students usually struggle with, and then after that we'll do this question, and then we'll see if we have the energy to do more. Okay, once again, it says Jacob has 4 coins. One of the coins is biased, such that when it is thrown, the probability of obtaining a head is 7 upon 10. The other 3 coins are fair. So once again, you have 3 fair coins and 1 biased coin. Jacob throws all 4 coins once. That means we don't need to consider different orders. The number of heads he obtains is denoted by the random variable x. Okay, the probability distribution table for x is as follows. Show that a equals to 5 and find a equals to 1 upon 5 and find the values of b and c. Basically, Zanana, I'm just taking out questions that are relevant. Okay, I've taken out questions that are relevant, and by the way, you can download this PDF from using the link in description. Okay, so I've already compiled a set of questions which I thought would be worthwhile to solve in today's stream. Okay, so what are we talking about? We're talking about A, and what's A? A is basically representing the probability of getting one head. Okay. Now the question hasn't specified where we get that head, whether we get it in a fair coin or whether we get it in an unfair coin. So let's see. Let's see how we can figure that out. So first, a good idea would be to write down the coins. So A, B, and C, once again, I'm going to call these coins fair coins, and D is going to be the unfair coin. So when we're talking about fair coins, let's write down the probability of getting a heads and the probability of getting a tail. So when we're talking about fair coins, that's 0.5, 0.5. But when we're talking about the biased coin, for that we need to know what the probability is. And the question has given us the probability of obtaining a head, which is 0.7, which naturally means the probability of obtaining a tail is going to be 0.3. Okay? Now, A is the probability, A is representing one head basically. So how will I find out, or how many ways can we get one head? Well, if you think about it, the number of ways that we get one head, let's write down one way. That is, you get a head on the first fair coin, and the second fair coin gives you a tail, the third fair coin gives you a tail, and the fourth biased coin also gives you a tail. Okay? But do not forget that this head, as far as the three fair coins is concerned, you can also get this head on B, and C gives you a tail, A gives you a tail, and D gives you a tail. And it's also possible that this head comes on C, which means that B gives you a tail and A also gives you a tail. Okay? And D also gives you a tail. And then there's another possibility. Okay? But first let's talk about these possibilities. 0.5 into 0.5 into 0.5 into 0.3. Okay, and this can be achieved how many ways? This can be achieved 3 ways. Okay, the probability of this will be the same, this will be the same. So instead of working them out individually and then adding them up, we'll simply multiply it by 3. Okay, then there is a fourth possibility as well. That is, A gives you a tail, B gives you a tail, C gives you a tail, and the biased coin, which is D, is the one that gives you a head. Okay, so what will be the probability of this? The probability of this will be, let's work it out, 0.5 into 0.5 into 0.5 multiplied by 0.7. And you don't have to consider any other possible outcome where the biased coin gives you a head, because there is only one. Okay? So let's work this out, see what we get. And notice that we don't have a lot of space to work with. Okay? So we have to be efficient with the way we utilize the space. So let's see what we get. We get, let's work it out, 0.5 cubed multiplied by, yeah, you can use combination here. Like for example, this is 3C1. Okay, you can use combination here, but I always prefer that you work it out separately. The solution is far more convincing when you work it out separately. Okay, and you don't really have more than 4 coins, so it's not that difficult to list every possible solution. And then 0.5 cubed into 0.7, which is 7 upon 80. So if we add this up, we get 16 upon 80, which if we simplify using the table of 16, we get 1 upon 5. So we have we have shown that A is in fact equal to 1 upon 5. Okay. Now let's find out the probability of either B or C. And if we have the probability of one, we can find out the other. Now in the last question, we found out the probability of getting 3 heads. Now to make things interesting, let's find out the probability of getting 2 heads. Okay. Now I'm not going to color code it. It just ends up taking a lot of time. We're just going to get straight to it. Okay. So one way to get 2 heads is that A gives you a head, B gives you a head, which is also a fair coin. C and D, both unfair coins, gives you a tail. Okay. Now another possibility is that A gives you a tail, B gives you a head, C also gives you a head. Let's write that down. And D gives you a tail. Okay. So once again, we have how many heads? We have 3. We have 2 heads. Okay. Another way is that A gives you a head, B gives you a tail, C gives you a head, and D gives you a tail. Okay, now if you think about it, all these three are the same. That means we just need to find out the probability of 1 and multiply it by 3. Okay, we just need to find out the probability of 1 and multiply it by 3. Okay, then there is another possibility. The other possibility is this: b equals to 3 upon 8. Okay, interesting. The other possibility is that A gives you a head, B gives you a tail, C gives you a tail, and it's D that gives you a head. Okay, D gives you a head. Now, once again, if you think about it, we're not going to change D, okay, just like we didn't change the outcome on D, but we will consider the different outcomes on the 3 fair coins, okay? And these 3 we can shuffle how many ways? We can shuffle 3 ways. That is, A gives you a tail, B gives you a head, and C gives you a tail, okay? And just like that, another possible outcome would be that A gives you a tail, B gives you a tail, and C gives you a head, okay? And D once again gives you a head. So that means this also can be shuffled how many ways? Can be shuffled 3 ways, okay? Now what are those 3 ways? I'll list them. So here are the 3 ways. One is the one that I've already listed, that is A head, B tails, and C tails. The other would be that A gives you, remember we just want one head from the fair coins. That is A gives you a tail, B gives you a head, and C gives you a tail. And the other is that A gives you a tail, B gives you a tail, and C gives you a head. Okay, I know it's complicated, but that's how it is. Okay, so that means we can find out the probability of 1 and simply multiply it by 3, because there are 3 ways. Okay, so this will be 0.5 cubed into 0.3, and because this can be done 3 ways, so we'll multiply it by 3, plus 0.5 cubed, because it's 0.5 into 0.5 into 0.5, multiplied by 0.7, and because this can also be done 3 ways, so we'll times it by 3. Okay, so let's see what do we get. 0.5 cubed into 0.3 into 3, that's 9 upon 80. And then 0.5 cubed into 0.7 into 3, that's 21 upon 80. So altogether, it's 30 upon 80, the value of B, or 3 upon 8. And then as far as C is concerned, for C, we can find out the probability. We can add up all the probabilities and subtract the answer from 1. So let's work that out. 3 divided by 80. Let me see if I worked it out already. So 3 upon 80 plus 1 upon 5, I haven't, let's work it out, plus 3 upon 8 plus 7 upon 80, 1 minus the answer, so that's 3 upon 10. 3 upon 10, or simply 0.3. And then you have E of x, which you can find out very easily, not a problem. Okay? Alright, now let's see what other question we can solve. Okay, let's solve the previous question, the one that I skipped, and then we'll stop after this question, okay? And I would encourage you guys to solve the remaining questions there are, okay? Now this question says a box contains 5 balls numbered 1, 2, 3, 4, 5. 3 balls are drawn randomly at the same time from the box. So notice the question says at the same time. That means we don't have to consider different orders, only different outcomes. May, June 2024 one? Okay, let me see if I can do that. Actually, the problem with solving recent papers is that Cambridge doesn't like that. If the paper is recent, then actually that's the reason why my channel got copyright strike. Let me see about that. Okay. I don't think I'll be able to solve that. Maybe I'll make a separate video on it. Okay. And I won't title it as May, June 2024. Okay, so a box contains 5 balls numbered 1, 2, 3, 4, 5. 3 balls are drawn randomly at the same time from the box. By listing all possible outcomes 1, 2, 3, 1, 2, 4, find the probability that the sum of the 3 numbers drawn is an odd number. Yeah, I know it's already uploaded, but I remember they sent an email regarding the number of years or how recent the question can be. So 2024, doesn't cut it. But let's see if I can come up with a workaround, okay? Anyway, by listing all possible outcomes 1 to 3, 1 to 4, find the probability that the sum of the three numbers drawn is an odd number. So that means irrespective, we have to list down all the possible outcomes. So 1, 2, 3. Now remember, we will not consider 1, 3, 2, and for the same reason, we will not consider 3, 2, 1. Why? Because all the what are these? All balls are drawn at the same time. Okay, so we'll not consider different outcomes because they're all equal basically. Okay, they're all equal. Okay, since all are drawn at the same time. No, it's not that we're rejecting repetition, it's just that we're not considering different orders because they're all drawn at the same time. Just like when you throw all the coins at the same time, you don't consider different orders, you only consider different outcomes. So that way here also, we'll only consider different outcomes. So one outcome could be that you get 1 in the first, 2 in the second, and then 4, and then 1, 2, 5. So notice that I've kept one fixed. Now let's consider 1, 3, 4. And we can also have 1, 3, 5. Any other possibility? No. Okay. Then 1, 4, 5. And then I don't think we can have 1. I think we've considered all the outcomes where the first number is 1. Now it could be 2, 3, 4, 2, 3, 5, 2, 4, 5. And I guess that's it. And then as far as 3 is concerned, 3, 4, 5. Yes, this is the last question that I'm solving. Okay, now let's see what's next. Let's see what the question says. By listing all possible outcomes, find the probability that the sum of the three numbers drawn is an odd number. Okay, so let's highlight. क्या सवाल है आपका? How much of S1 is complete on my channel? Quite a lot. I think the only thing I don't have is permutation, combination, and normal distribution. I don't think I have normal distribution, but I will complete it before October, November 2024. Don't worry. Okay. So let's list all the outcomes where the sum is an odd number. So this will give us an odd number. 1 plus 3 plus 4 will give us an odd number. So basically, 2 odds and 1 even will give you an odd number. Okay. If you add 2 odd numbers and if you add 2 even numbers and 1 odd number, you get the result will be an odd number. Okay, so 1, 3, 4 is not going to cut it, obviously. Let's see, 1, 3, 5, 5 plus 3, 8, 8 plus 1. Okay, this is an odd number. And what else? 2, 3, 4 will give us an odd number, and 2, 4, 5 will also give us an odd number. So that means altogether there are 4 from a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4 out of 10, which is equal to 2 upon 5. There you go. Okay, now part 2. Part 2 says find the probability that L is 4. Now what's L? L is that the random variable L denotes the largest of the three numbers drawn. So that means let's circle now the outcomes in which the largest number drawn is 4. So there's 1, 2, 4. There's 1, 3, 4. There is 2, 3, 4, and that's it. So the answer to part 2 is simply 3 upon 10, which we cannot simplify any further. Okay, then let's do part 3. Part 3 says draw up a table to show the probability distribution of L. So here's L, and here is the probability of L. Now remember, what's L? L is the largest number drawn. Now, how many possible options do we have for the largest number drawn? Let's write that down. So it's possible that the largest number drawn is 3. It's possible that the largest number drawn is 4. It's possible that the largest number drawn is 5, and that's it. There's no other outcome that we have to consider. Now, what's the probability that the largest number drawn is 3? Okay, let's see. The largest number drawn is 3. As you can see from the 10 outcomes, happens only once. That is when you have 1, 2, 3. So the probability is 1 upon 10. What is the probability that the largest number drawn is 4? The question has already made us figure that out, and that is 3 upon 10. Now for 5, you can either use the outcomes or you can use the sum of probability. So sum of probability, if I use that, that would be 1 minus 4 upon 10, that would be 6 upon 10. But let's see how many ways we have the largest number drawn as 5. Okay, so I'm going to I'm going to put a dot on the left hand side. So here's 1, here's 2, here's 3, here's 4, here's 5, here's 6. So it's a total of 6 out of 10 times. And there you go. We have now also completed the probability distribution of L. And then part 4 is pretty straightforward. All you have to do is find out the expectation and the variance, which I'll write down. E of x would be equal to 3 into 1 upon 10 plus 4 into 3 upon 10 plus 5 into 6 upon 10, whatever that is. And the variance of x would be 3 squared into 1 upon 10 plus 4 squared into 3 upon 10 plus 5 squared into 6 upon 10. And from this result, do not forget to subtract E of x, the whole thing squared. Okay? All right. Now, so I will encourage you guys to try the rest of the questions. I'm sorry I can't solve the May June 2024 question. It's a bit risky because it's recent. I know the paper is already out, but there is a certain rule. I don't remember what that is. I will take that question out separately, not mention that it's a May June 2024 question, and then solve it, and then I'll post it. Okay, but for now, that's enough. I will stop here. In the next stream of S1, I'll either do binomial or I will do normal distribution. Binomial or normal distribution, but I will also do permutations and combinations. Don't worry, I'll do plenty of streams of permutations and combinations before the October-November exam. Okay, so if you guys have your exam in October-November, don't worry about it. But before you go, if you guys can just like the stream in case you haven't done that yet, I'd appreciate it. And that's it. I'll stop here. See you guys inshallah soon. Take care. Allah Hafiz. How many videos permutation and combination will take? It will take around 4 or 5 videos. If I'm doing a stream, I'll do 2 streams on permutations, 2 streams on combinations.